This is 1.7 linear and absolute value inequalities. The solution set to an inequality is the set of all real numbers for which the inequality is true. So you remember when we had an equation like x equals 3? There's only one number that can make this equation true, and that would be 3. 3 equals 3. Well, for an inequality, you have many different numbers that can make this true. So if we're looking at this inequality, you could have x is equal to 4. That's greater than 3. You could have x is equal to 3.1. That's greater than 3. You could have x is equal to 100. Or x is equal to pi. We could just keep going on and on and on. So we represent all of these numbers as an inequality. This means that all the solutions are greater than 3. So you can write these solution sets in different ways. One is called set builder notation. And set builder notation means you just use these little squiggly brackets. And you say it like this: all x such that x is greater than 3. That's how you would read set builder notation. You can also graph it. Greater than 3 we know is this direction, right? Okay, well, we're going to learn in just a few minutes about brackets and parentheses. Since this is strictly greater than, we're going to put a parenthesis there. So that's how you would graph x is greater than 3. And your graph helps you to write it in integral notation. On the left, we have a parenthesis, and it begins at 3 and goes forever to the right. So you would write that as 3, comma, infinity. And infinity always has a parenthesis on it. So what we're going to talk about in the next couple of pages is how parentheses and brackets are related. So for parentheses, you do not include the endpoints. So that would be something like less than or greater than. And for brackets, you do include the endpoints. So that would be something like less than or equal to or greater than or equal to. So every time you see one of these, you use brackets. Every time you see one of these, you use parentheses. So this is where we're talking about open and closed, or you can even call them half open, half closed intervals. See how this has a parenthesis on both sides? It's considered open. You start at some number, go forever to infinity. So here, it starts at A and goes forever to infinity. And the second one, we're also calling it open because both sides have a parenthesis. And the third one side is closed. If you have a bracket, we call that closed. Now some people would call this third one half open, half closed. Notice how, let me give me a highlighter here. Notice how we have greater than, we have less than, we have a parenthesis, and we have a parenthesis. And then notice how we have a greater than or equal to, a greater than, less than or equal to, we have a bracket, we have a bracket. So that goes back to what I was saying on the previous slide. If you have an or equal to, that's when you use a bracket. You represent all real numbers as the entire number line is considered open because it goes from negative infinity to infinity. So let's do some examples. If we wanted to graph this inequality, it starts at negative infinity, so it starts way down there, and it's going up to negative 9. It's going to stop right there. Is it including the negative 9? No, so we put a parenthesis there. So how would we write an inequality that means this graph? It's everything less than negative 9. So you would say x is less than negative 9. We do not put an or equal to because this is a parenthesis. Okay, so how about the second one? This one says we start at 0 and we stop at infinity. So we're starting at 0 and we're going towards infinity. That's this way. Do we include 0? Yes. So if we wanted to write an inequality for this one, it's everything greater than or equal to 0. X is greater than or equal to 0. Remember this, an equal sign makes an equation, like x equals 3. An inequality sign makes an inequality, like x is greater than 3. There's only one difference between solving an inequality and solving an equation, and that is right here in these bold letters. If you multiply or divide by a negative, you must reverse the inequality sign. Okay, so let's see how that works. Here are some examples. Pretend like this is an equation and just solve it. If you were solving this, you would add 9 to both sides. You would get negative 3x is greater than 9. Now you divide by negative 3. Since you are dividing by a negative, you must reverse the inequality sign. So this would be your solution. How would you graph x is less than negative 3? Less than is to the left. It doesn't have the or equal to, so we put a parenthesis on it. So how about the next one? We're going to subtract 2. So we get negative 5x is less than or equal to 5. We divide by negative 5. Again, we're dividing by a negative. So we must flip the inequality sign. So this is our solution. X is greater than or equal to negative 1. Greater than is to the right. Or equal to means we use a bracket. So what if we wanted to write both of these in interval notation? This one would be negative infinity to 3, parenthesis. And this one would be bracket negative 1 to infinity, open. Oh, here's a good one. What should we do first? I bet you know by now. Yeah, I would get rid of the fractions. So I'm going to multiply everything by my least common denominator, which is 4. When I multiply this one times 4, half of 4 is 2, so I get 2x. When I multiply this one times 4, I get negative 12. 1/4 of 4 is 1, so I get 1x. And then 2 times 4 is 8. Subtract x from both sides. Add 12 to both sides. So I get x is greater than or equal to 20. If I wanted to graph that, I would just go to wherever 20 is on my number line. It's greater than, so we know it's this direction. And it's or equal to, so we have a bracket. So that would be bracket 20 infinity, parenthesis.